Welcome to Star Delta online engineering classes. In this session, we will see one rectifier circuit from power electronics subject. So let's get started. In this, we will see single phase half wave rectifier with RL load. This is the configuration of this rectifier. As we can see, one single phase AC source is given, one thyristor or SCR, and there is one load which is consisting of resistance and inductance. Is will be the supply current to this thyristor and I naught will be the load current for this circuit, and Vt will be the voltage across the thyristor. As there is SCR or thyristor is present, we know until we provide a gate signal to this thyristor, it will not turn on, right? So we need to apply a gate pulse to this thyristor to get turned on. So let us discuss about the working of this rectifier with the help of the waveforms. But before that, we will define the supply voltage like Vs is equal to Vm sin omega t. Okay, it will be the purely sinusoidal supply. So let us assume that we have applied a gate pulse to this thyristor at omega t is equal to alpha. Okay, hence from the instant alpha itself, the thyristor will start conducting, right? But before alpha, that is in the interval from 0 to alpha, the thyristor will be in the off condition, right? The thyristor will not carry current, so the supply voltage will appear across the thyristor, correct? Now we will see the waveforms. These are the waveforms associated with this rectifier circuit. This is the supply voltage waveform, which will be the purely sinusoidal. This is the output voltage waveform. This is supply current and output current waveform. And this is the voltage across the thyristor. Okay. Now we will see the operation of the rectifier interval by interval. Okay. Now at alpha, this is alpha actually, this is the point alpha. At alpha, we are providing a gate signal to the thyristor, and from that instant itself, it will start conducting. But before alpha, that is during the interval 0 to alpha, what will happen? The thyristor is in the off condition. So the thyristor will act as an open switch. Okay, it will not carry any kind of current. So the supply voltage will appear across the thyristor, right? Now, as it is not carrying any kind of current, so the load voltage during this condition will be 0 and the supply voltage will appear across the thyristor. It is shown in this waveform, right? The current will be 0 during this condition. Okay, now at alpha we have provided one gate signal, right? So from that instant only it will start conducting. During this condition, thyristor will act as a closed switch, okay, and it will carry the current from source to load. Okay, now because of the current flow from source to load, the supply voltage will appear across the load, right? And the we can see here the load voltage waveform, right? That is output voltage waveform. Okay, now as we can see from here, our load is consist of the inductor also, and we know the property of the inductor, like it will not allow sudden change in current. Okay, so inductor will allow the output current to flow or to increase very slowly, like, right? We can see this from here. At the instant alpha, the thyristor will start conducting, right? From that instant itself, the current will rise very slowly. during this process, inductor will start storing the energy, right? And at the some point of time it will achieve its maximum position or maximum point, and then it will start releasing the energy. So the current will also get reduced, like, right? We can see from this current rises slowly and it will achieve maximum value, and it will release the energy, or it will start decreasing. Okay, but as current is rising slowly, it will not achieve its zero position instantly, right? It will take some time. So we can see this from the waveform. At omega t is equal to pi, at omega t is equal to pi, output voltage is zero. Okay, but there is current in the circuit. Okay, so thyristor is still in the on condition. Okay, now let us assume that current is in the circuit goes to zero at omega t is equal to alpha. Okay, so during the interval pi to beta, there is pi to beta, the thyristor or SCR will come across reverse voltage. Okay, because the during the negative half cycle, the supply voltage waveform is in the negative phase, right? So output voltage will also goes into the negative phase. That is, it is known as the reverse voltage, which will appears across the thyristor. Okay, this is also known as the reverse anode voltage. uh, here here beta is known as the extinction angle, right? Okay, the extinction angle is the current or load, the current or load current which goes to zero, right? This is known as the extinction angle. Okay, and the extinction angle is measured from zero position. Okay, this is the zero and this is the beta. Okay, extinction angle is measured from zero to from the zero position. Okay, now in the interval beta to 2 pi plus alpha, as there is no any positive gets pulse applied to the SCR, so there will not be any kind of conduction during this period. Okay, thyristor will remain in the off position, right? At 2 pi plus alpha we are providing a positive gate pulse to the thyristor, so it will start conducting. It will thyristor will be in the on condition, and process will get repeated, right? Okay, now what is the conduction angle, right? If we can see beta from in the interval beta to 2 pi plus alpha, we are not providing any kind of gate signal, then thyristor will be in the off condition. Okay, now what is the conduction angle? We have seen the extinction angle. Now we will see the conduction angle, right? What is conduction angle? The conduction angle is the interval from which thyristor or rectifier is in the on state. Okay, look, at the instant alpha we have provided the gate pulse. From that instant only thyristor will carry the current, right? So at alpha it will starts conducting, it will carry the current, and at the beta the current approaches to zero. So the this is the conduction period or the conduction angle, and the conduction angle will be defined as beta minus alpha. Okay, now what is the circuit turn off time? This is very important concept, right? During commutation process, what is commutation? The turning off of the SCR or thyristor. Okay, during turning off process, the reverse voltage is applied across the SCR. Okay, for some time period, which is known as the circuit turn off time. Okay, from this waveform we can observe that the this is the thyristor voltage, right? And for this interval the reverse voltage is applied across the thyristor. Okay, this is the interval from beta beta to 2 pi. Okay, for this interval the reverse voltage is applied across the thyristor. It is given by omega tc, so omega tc will be equal to 2 pi minus beta. So circuit turn of time tc will be equal to 2 pi minus beta divides by omega. Okay, and now this is all about the circuit operation. Okay, now we will see the voltage equation of the circuit. Okay, as we have discussed, like during turn on condition, the supply voltage which will completely appears across the load because thyristor will be in the on condition. So, and during that condition, supply voltage will be equal to load voltage. This is given in this equation. This is our supply voltage Vm sin omega t, and R into I naught will be the drop across the resistance. I naught will be the output current. Okay, and this is the voltage across the uh, inductor, right? L di by dt. Okay, now during on condition, as we can see from here, during on condition, right, we need to calculate the load voltage, and output will come across the load voltage like from alpha to beta. Okay, so average load voltage is calculated by 1 divided by total time period alpha to beta into Vm sin omega t d omega t. And if we calculate this equation, or if we solve this equation, we will get this expression, right? And there is for calculating average load current, we need to just divide it by resistance. Okay, this is all about the operation and discussion about the waveforms of single phase half wave rectifier. Okay, thank you.